Okay, so now we're going to take a look at measuring initial rate using the clock method. So this example given here, right, is where your thiosulfate, right, reacts with your HCl to give you a yellow sulfur, right, being produced, which is actually a suspension. All right, so this rate of reaction is investigated, right, by measuring the time taken for the sulfur, right, to actually obscure the cross. The cross, which is printed on a piece of paper, put below, directly below the conical flask. So when you observe and you see the sulfur forming, the time that it takes for it to obscure, which is a certain amount of sulfur, right, which is constant for every experiment. So we take a look at how long it takes to obscure the cross, all right? So the rate will be inversely proportional to the time taken, all right? So this is another way that we can measure initial rate. Okay, so a quick check for you guys. So because of this online recording, so just going to go through this with you. The purpose of adding water is to keep the total volume constant. How much? 80 cm cube. All right, so that the volume, right, is directly proportional to the concentration. All right, so deduce the order of reaction with respect to thiosulfate and HCl. So when we compare experiment 1 and 2, right, keeping HCl constant, all right, when we double the volume, what happens to the time taken? The time taken is half, which means that the rate is also double, all right, when we double the rate of reaction. Okay, so my explanation is from comparing 1 and 2, right? So we're comparing it downwards. Okay, so nonetheless, the order of reaction with respect to thiosulfate is 1. Okay, so because when the concentration doubles, the rate also doubles. Okay, concentration is halved, the rate is also halved. Okay, so when we compare experiment 3 and 4, thiosulfate kept constant. When the volume of HCl is halved, the time remains the same. So order of reaction with respect to HCl is actually 0. Okay, so can we actually use both methods simultaneously? The answer is yes. All right, so we're going to give you an example of this bromomethane hydrolyzed by KOH. All right, so a series of experiments was conducted, blah, 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 deduce the order of reaction with respect to each of the reactors. Okay, so at time equal to 0, if you draw the tangent, right, if you draw a tangent at t equal to 0 for both curves, you realize that actually the gradient is basically half. The gradient is actually half. All right, so the gradient is half when the concentration is half. So that means the order of reaction with respect to KOH, sorry, the order of reaction with respect to CH3Br is 1. All right. So you can see that when the concentration is doubled, the rate which is found by the tangent is also doubled. All right. Then we use the half-life method to find for the order with respect to KOH, because if you look at the graph, right, we are monitoring KOH. So we can actually find out the T half, which in this case is constant. So the order of reaction with respect to KOH is 1. Okay,